Hello, everyone, and welcome to my Penny Oxidation Interactive Ad- Advanced Concept presentation. So for this week, basically what's going to happen is I'm going to take a group of pennies, break their copper, or take their copper out, and stick them to these nuts I have right here. And I'll be showing you a couple of other things along the way, but that's the big thing that's going to happen. So what I need for this experiment is obviously pennies and nuts. But what I also need is some water, some vinegar I have right here. Don't know how well you can see that, but there's some in here, and I'm trying to be careful not to spill it. A plastic spoon, a teaspoon of salt right here, and a paper towel that I have just sitting right here. You can see that on camera. Everything's right here. So yeah, so for the first part of this experiment, I just need to take my bowl. I don't know if I mentioned that in the material entry, but you need to have a non-magnetic bowl. That's the thing. So I just grabbed a bowl I had my from the kitchen, and I believe this one's made out of lead and a little bit of glass or something, maybe plastic. So it should be all right. So first step, I take this 1/4 cup of white vinegar. You can use regular vinegar if you want. Pour it into the bowl. And, let me just adjust the camera so you can see what I'm doing. So, okay, there's the bowl right there. Next, I take my 1/4 tablespoon of salt, add it in, and with the plastic spoon, you just stir up the solution. I'm going to get a little bit of extra light so I can see when the salt's gone. And you stir up the salt in the vinegar until the salt is completely dissolved. So I'm going to pause the video briefly and be back with you when I'm done with this stirring. Alright, I'm back. That took a little bit longer than I thought it would. I would recommend you not use a white bowl like what I did, because I had a hard time telling if when the salt was dissolved or not. So anyway, so the next step of this experiment is simply you take your pennies right here and you put them into the solution. And this step might take a while. It could take, I think, between like 5 to 15 minutes, if I recall correctly. But basically, what's going to happen here is that the mixture of the white vinegar and the salt as a compound is going to draw out the copper or the electrons of the copper on the pennies into the solution, and we will see in who knows how many minutes. I'll be keeping track of that, what the pennies come out looking like afterward. So I'm going to pause the recording again, and I'll be back with you guys when the penny starts showing some notable changes. Just a quick thing I'm noticing just a couple minutes into the bowl dissolve or the pennies reacting with the solution here, that some of my pennies, if you didn't notice in my when I showed them off to you, some of them were dirtier than others, and it looks like some of the built up dirt and copper on the pennies is starting to dissolve. I'm not going to take them out just yet because I'm waiting for a little bit of a color change, pigment change in the pennies. But one thing that you will start to notice right off the bat when you put the pennies in the solution is that they'll start to clean themselves. As let me see if I can at least get this into view with you guys. So basically, with the pennies in there, the dirty pennies are actually starting to become quite clean in there. There also looks like they're starting to get a little bit of a tint of pink in there, so it's coming along nicely. But basically, if you use dirty pennies, any copper ink that's left over on the pennies is going to slowly be cleaning itself because the electrons from that is being extracted by the solution, or it's being dissolved, you could say as well. So this is actually a good way you can clean your coins if you, for well, whatever reason you may one day want to clean your coins for. But anyway, I'll be back again once penny, when the copper starts to react more with the solution and it breaks down. I'm back. It's about an hour or so later, and the pennies have cleaned off quite well. 1 second. If you look right there, the camera's not picking up very well because of the reflection, but this penny that was once dirty is pretty dang clean now. So from here on, I'm going to do two different things. One, for most of the pennies, I'm just going to sit right here on the paper towel. Let me just turn so, and gonna have to move the bowl out of the way. And okay, so yeah, I'm just going to set some of the pennies on this paper towel for them to dry and see what happens when they are exposed to oxygen now after you take them out of the solution. Now, one thing also is that, and this is what I had the water right here for, if you put the penny that's covered in the vinegar salt solution in water like so, the reaction stops. Why does this happen? Well, for one, the solution is just washed off. But the main reason for it is because, if you remember, the solution in the bowl was reacting with the copper dust or whatever it is. I can't remember, to be honest. And it was basically dissolving it. Once you put water inside or once you put a penny with the solution inside a bit of water, I can't show very well on camera because of the cup that I use, but basically what happens is that the oxygen and the HO2 washes away most of the vinegar reaction because they are both liquids, and they don't react, and they split apart really. As for the pennies that I have right here on the paper towel, and with some of this stuff out of the way, I'll show you guys. There's going to be a certain reaction that happens with these pennies a little bit later, but some of that's going to take some time. And if you can't tell from the light right here, these are pretty dang clean pennies now. Let me see if I can get these into camera view. So yeah, that's how you basically clean your pennies. And as for the next step of this experiment, I'm gonna have to cut again to give this hopefully just these pennies just a few minutes of time to oxidize with the air, and I'll explain what happens when I come back. One thing I actually forgot for a second is that I had these nuts right here. So I'm setting the pennies off to the side for now. I'll come back to that in a little bit. But now we got the nuts, and in the bowl of salt vinegar solution right here, there's a dissolved carbon in here. So I'm gonna put the nuts in now, and we'll see what happens. Knock that one over. And what should happen, and I'm going to turn on the lights. Sorry, this is not great recording because the bowl's white. Oh boy. I'll be right back. I got to fix this. Alright, so I'm back. And when we take the nuts out of the solution right here, we can see that, maybe not very well on the camera, but at least from my point of view, the nuts have darkened quite a bit since I put them in the vinegar salt solution right here. So, why has this happened? Well, there's a couple reasons for that. For one, if you remember the first step of this experiment where we put in the pennies into the solution, it extracted any lingering copper bits that is built up on the pennies over time, and this solution dissolves them and cleans them off. But that remaining copper is still inside the bowl. We know that it's by the law of conservation of mass. You cannot destroy it by like any mass or energy and that kind of stuff. There's a conservation of energy law too, but basically the copper is still in the bowl. It's still floating around. There's a couple of bigger specks as well that are showing. I'm not going to pour it over my computer, but In terms of why it is the bolts have darkened as a result of putting them in the solution, it's because that copper is now sticking to the nuts. As for why it's sticking to the nuts, it's because when it dissolved off, the copper dissolved off of the pennies, it was extracting the electrons from the pennies. And with those electrons now just floating in the bowl, or although it could also be attached to the solution as well. But basically now that I've introduced a nut to it, those electrons that were extracted from the pennies are now sticking to the nuts. And that is why it's starting to darken. The material of the nuts is likely positively charged, and that's why the electrons are that were dissolved and broken apart from the copper are now sticking to it. So that's why um, when you put nuts into your bowl right now, or maybe even any kind of metal that is positively charged into your bowl solution after cleaning off your pennies, then they're going to start to darken because the electrons are now starting to be attracted and sticking to the nut. Now, with the pennies I got here, let me turn the slide off so you can get a better image of it. Let me get it into camera. All right, so it's only been a couple of hours, and the pennies haven't changed a whole lot, aside from this one. Let me see if I can get this into view. Kind of, from the looks of it. You can kind of see like it's starting to rust a little bit almost. So basically, and all the pennies are going to end up like that. And except for, of course, the penny that I put in the water right here, and it washed away the solution from the penny surface. If I were to take it out, you wouldn't see the same reaction. But what happened in the solution basically was that it broke apart when it was dissolving the copper. It also dissolves the copper sheets on the penny. It loosens up the ionization or the energy attraction between the coin and the copper sheet on the penny. And now that I've left it out for a couple of hours, just to sit there and dry, a process known as oxidation has happened. And what this has done is that with the loosened up copper, the oxygen and the loosened up copper are starting to react with each other, at least on the one penny that I showed you in the camera right there. And it's starting to look a little bit rustic. If I leave these pennies out for long enough, then all of them are going to start to look that way. But at least with the one that's showing it already, I think this one was a very freshly clean one, as opposed to the ones that are completely dirty. Like this one right here. This was one that was really dirty, but it's still relatively clean. There's from the looks of it, a little bit on the back starting to show. It's starting to turn a little bit greenish, rustic. Like that's how you can kind of tell, almost a little bit cyan almost. But yeah, basically when you leave the pennies in the solution, they're cleaned off and they're broken down. But you want to put them into water right away because otherwise the loosened up copper, um, the atomic attraction of the copper in the penny will weaken as a result of the solution. And then once you leave it out to dry, it'll start reacting with oxygen. And through the process, as I said, oxidation, and it'll start to rust again almost because of, and it'll change color because it was left out too exposed. Now, if you want this process to stop, all you have to do is like what I did with the penny earlier. You just take your pennies, throw them in the water, and just let them sit there for a little bit and just let the water wash away the solution. So yeah, that's this week's that was this week's interactive presentation. Definitely longer than it probably should be from the recording, but that's all I have for you folks. See you next week. Goodbye.